Hi everyone, welcome to my channel. This is Leo and let's do some more Leetcode problems today. Today's problem is called bulls and cows. This is actually a game and we write down a secret number and ask your friend to guess what the number is. When your friend makes a guess, you can provide a hint with the following info. So the first is the number of bulls, which means the digits in the guess that are in the correct position. We can take a look at an example here. So we have this one. The input is secret equals to 1807 and guess is 7810. So we have this 8 at the exact same position for both numbers. So 8 is counted as a bull. Okay, next, the number of cows, which are digits in the guess that are in your secret number but located in the wrong position. So the number of digits in the guess that could be rearranged so that they become bulls. Okay, so here we have, other than 8, we have 107, and here we have 710. They're exact same numbers, but in different positions. So they are counted as cows. So the final result will be 1 bull and 3 cows. So that's what was instructed for us for the output. Okay. So how can we solve this problem? We can start from looking at this, okay? If we use like a two-pointer solution, we point to this one, we point to this one, and if they're not the same, we continue and we find a bull, and we continue, we got nothing, we continue, we got nothing. That's not actually how we do that, because you can't save the pattern of the secret and tell what is a bull, what is a cow. Okay, so we have to somehow save it in a map or something to record its frequency for each digit. So let's say we have this. We have secret equals to 1807, and we have a hash map which records its frequency. 0 is 1, 7 is 1, okay? And we have a guess, 7810. We can iterate through this guess number. So if the first number exists in the map, we know we at least have a cow, right? And if it's the same in the same position with the secret number, we have a bull. Okay, so let's see what it is. It was in the map, and it was not the same position with the secret number, so we know we have a cow. Okay, and after this, since we processed this part, we have to decrement it from our HashMap. Okay, so that we don't have any duplicate counts. And here we have 8 at index 1, and it is in the same position as in the secret. So we have a bull. Okay, and don't forget to decrement the frequency here. And now we have a 1, which is a cow. And last, we have a 0, which is also a cow. So the final result for this would be 1A, 3B. Okay, that looks good. Let's take a look at another example. We have secret equals to secret equals to 1, 1, 2, 3, and guess equals to 0, 1, 1, 1. Okay, if we do the same thing, the map would be 1, 2, 2, 1, 3, 1, like this. And yeah, we can start iterating from the guess number. So first We have a 0. Do we have a 0 in the map? No, so we do nothing. Here we have a 1. Do we have 1 in the map? Yes, of course. We're going to decrement it and then judge whether it's a bull or cow. So judging from here, we have a bull. Okay, and we go next. We have a 1. Good. Decrement it. And is it a bull or a cow? It looks like a cow, okay? Because 2 is in the same position in the secret number, so it's a cow. Good. And let's go next. 1, but now frequency is less than or equal to 0, okay? So we just ignore it. So the final result would be 1A, 1B, which is the right answer, okay? But we have to think about another scenario, like 1, 2, 3, 1, and guess is 0, 1, 1, 1, okay? We can also do this because we have a frequency map. And here we have a 0. We got nothing in the map, so we just continue. Here we got a cow, okay? Oh, it's going to be 2. We got a cow, so we're going to make cow plus plus and decrement this 1, okay? And next we have another cow, okay? And decrement this to 0. But here we encounter a problem. We have a bull here, but we don't have any other matching element in our hash map. So what does it mean? That means we've counted a cow wrongly. So this one or this one of them shouldn't be a cow. Instead, this should be something to be ignored. Okay, so in this case, if character is a bool and its frequency, get character, is less than or equal to 0, that means we made a wrong allocation for one of the characters. So we have to decrement the cow, the number of the cows, okay? So we have to decrement that and then bool plus plus. So in this case, we have the right answer instead of 2 cows, no bull, or 2 cows, 1 bull, which were also wrong, okay? So I think that's pretty clear. So this is a bit tricky, but once you get this example, I think you have a better chance writing the right code. Okay, so now let's code it out. So we need a frequency map. And the purpose of this map is to record 2-character array to record the frequency of all the digits in the secret number. Okay, so map will put c map dot get or default c0 plus 1. Okay, so now we have our map. Next, we're going to iterate through the guess. Okay, so let me just write it down. We have to count the bulls and the number of bulls and the number of cows, which are initialized to 0, and we have the guess length initialized to n, and now we can iterate through it. That will be guess dot character at I. Okay, so like I said, if we have that in our hash map, okay, and if it's also secret dot character at I. It's in the same spot. Okay, so we know we have a bool. Okay, it's a bool or bools? Bools. Okay, we have a bool, but like I said here, if the frequency becomes negative or 0, map.getCH less than equal to 0, that means we have a wrongly calculated cow, so we have to decrement that. Okay, and if it is not the same, if it is in the map, but it is not the same position with the secret digit, we know it's a cow. Okay, we have to calculate if map.getCH is larger than 0, we know it's a cow. Okay, and after all these we can decrement, but we don't have to do that right now. Okay, so yes, else it is a cow, and we have to put the character map.getCH -1. Okay, yeah, I think that should probably conclude it. And we're just going to return integer dot toString bools plus a plus integer toString cows plus b should be our answer. Okay, some typos. Okay, that runs perfectly. So let's now analyze the time complexity and the space complexity. For time, since we're doing a traversal here and another traversal here, but it should be on in the worst case. And for space complexity, we have only a hash map, which has at most 10 keys. So that should give us a constant space, and we're not using any other data structures. Okay, yeah, that should be it. Let's submit it. Perfect, it passes all the test cases. Thank you so much for watching. If you liked the video, please like it and subscribe to my channel. I'll see you in our next video.